Hello ladies and gentlemen, starting off Algebra 2 year with 2.1 notes, relation and functions. It's going to be a very Algebra 1 review, but this is going to set up something for the whole year, so you got to make sure you're awesome at domain, range, is it a function, and if it's not. Setting up some basic things here. All of this is not expected to be copied, but I will try to highlight the most important parts. Vocab wise, you want to make sure you're okay with ordered pairs. Remember, ordered pairs mentions anything that is an x and y coordinate, and you put it in parentheses to signify that that is a point. That's all that means. A bunch of different ways that we can show a set of ordered pairs. Notice not highlighting these. Those are not as essential. Just like you would think for English classes, bold words, definitely important. Now here's something super important. X values. The official name for X values is known as the domain. We're going to try to keep domains green everywhere because this is going to be a running theme the entire year. You never get to forget what domain is. Y values, we call that the range. So love them, hate them, at least at this point. Those definitions are going to be the same forever. So we're going to get good at them. When we talk about graphs that are distinct points, we call those discrete. We'll see a few examples of those. And connected ones that are smooth, ones that hit infinite amounts of points, those are known as continuous functions. All right, very exciting. So, an example of a function then would be something like amazing. But something to point out, remember it said set. Set means we have to use set notation. Oh, that was horrible. Kind of look like seagulls, but they're called braces. Here's the trick. If this wasn't a function, literally here would be the only difference. Something like that. Because here's the whole point. Not a function only means that you can't have repeats in the domain. Notice when you looked over here, all these guys were unique domains, no repeats, so that's what makes it count as a function. These are all points, so these would also be considered discrete, even if they aren't a function. And we get to graphs, something that would be considered a function, straight line. Something that would be a function. And the way that you know it is if you look over here, vertical line test. This is something you can do at any point, super useful, is literally go along the graph with a vertical line. This could be your pencil, a finger, an actual ruler, whatever. As long as it's only hitting one point at a time, no overlaps, that guy counts as a function. Not a function. Right here at the edge, we only got 1 point, but as soon as you get in, boom, boom. Overlapping, not a function. Alright, so that's all we're looking for vertical line test. Running some examples, I would suggest if you need extra help, return to the right column. We're going to try to run through the left. So first, remember, domain, range. We're going to try to color code these. So range, domain, boom, 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 boom. Very painless. Here's what that does for us. First, domain. You want to make sure that you write these in order. So smallest number or most negative first, counting up. And since these are random numbers in a set, give them the seagulls. Range, same thing. And notice, none of the domains repeat, they're all unique. So yes, that is a function. Next. All right, remember, that guy is domain, so all those. And range, all those. All right, putting them in order. Range, putting them in order. Y's end up being a little funky. Now you have repeats here. You don't have to write them both. In fact, it's less correct writing them both. You only record them once. Here's a trick. These are both Y's here. Yes, it is still a function. Because, here's the important thing to note. Y's can repeat, but those X values, those domains, cannot. Alright, so that guy still counts as a function. Alright, these are what they call mapping. Or relation mapping, function mapping, whatever you want to think of it. I think they're like pirate ships, so they're coming along each other. Let me draw. Fantastic, it's a pirate. So, if you're thinking of these like cannons, -4 shoots, -2 shoots, 5 shoots. 5 can't shoot 2 places. That means your domain is repeating, so this guy is already not a function because of that 5. But we can still fill out all the information even though it's not a function. Get them all in order. Cool. Hey, we got some actual pictures. So, anytime you're working off of a graph, remember graphs, you always have to worry about vertical line test. And right here, these ones are on top of each other. They're hitting them at the same time. Boom, boom. means that guy is not a function. Ooh, that's so aggressive. Get out of here, ruler. Not a function. So going through these, remember, domains are x's, so I'm using the x numbers, so it's really easy to get turned around. So I'm not writing that repeat of the -3. And now we're talking y, so a little messier. Come on, junky handwriting, we can do this. Nailed it. Shapes can get weirder when you hit both of these. Anytime you have a geometric shape like this, just look at that. Everybody's overlapping, totally not a function. Go over to this one. This angle, right here, only has one point. Call that the vertex. We'll worry about that guy later. But as soon as you start moving along, boom, doubles. Unfortunately, that guy is not a function. So let's talk domain. Domain means we're looking at x. When you have a picture like this, do remember that means you are looking to the right and to the left only. So when I go left, the leftmost part is at -4 because you're thinking x's left and right. And arrows. Remember, arrows go off towards, well, they go on forever, and they go off towards infinity. Remember, that's what the figure 8 sign looks like sideways. So you have positive y and positive x infinity up here, and then this guy also goes off towards an infinity forever and ever and ever, amen. Here's the point. Your x's start at -4, your graph goes on forever to the right. So all your x's are bigger than 4, or equal to that -4. So inequalities are possible. This guy is a continuous function, so we need inequalities, versus discrete, which we could leave in set notation. Let's talk range. I almost walked away from that one. We got to think y's. All right, and y direction, we're talking up and we're talking down. So when we go all the way up the graph, the highest point of the graph is positive infinity for the y's, because the numbers get bigger and bigger forever. Right on the side, positive infinity. Bottom side, when you go down, the numbers get bigger and bigger, but they are negative. So we have both infinities. That literally means every number that exists. Every number that we call real is our answer. All real numbers. You don't have to write that whole thing though. We give it a double barred R. It's like it's bolded. And you can just write that and you don't have to write all the words. Alright, and our last set. If they don't give you a graph, you're ready to do all this in your head. I'm kidding, of course. Use a calculator. Come on, people. Desmos is going to be your best friend. One of the biggest things I can recommend for your notes is to have this open in a separate tab in case you ever need to use it. You get to use it during quizzes and everything anyways. Y equals -x² plus 3. I'm going to go to my Desmos and I'm going to type that in. If this is your first time using Desmos, a few of the key commands are a little specific to computers, so I'm going to kind of narrate what I'm doing here. So y equals negative, you can just use the dash, x. Now we need an exponent, so you write that with the caret right here. Gives you any power there in that spot. Squared. Notice the cursor is still up in the exponent, so you need to press right to drop down. Hooray! I know, a lot of work. Alright, so checking this guy out, we could do all the work here in Desmos if we wanted, but I'm just going to take him back home. Thanks, computer. Alright, so the point of this guy from the vertical line test. 1 point, 1 point, 1 point, 1 point, 1 point. Okay, definitely a function. Okay, domain. So if you look at the x's, they don't draw them on Desmos, but remember these go on forever. So if we're looking at x's, go all the way to the left, we have an arrow, which gives us negative infinity. If you go to the right, we do have a right arrow, even though I know it looks like it's going down, it's still going right. That is a positive. When you get both infinities, remember, that is our magic all real numbers answer. Let's talk range. Our y's. We got the arrows dropping down. Y's go negative when they go towards the down infinity. And what's the highest y? If you look in here on the grid line, highest y is 3. So really it's kind of like we hit the ceiling at 3. Okay, so we don't get to use all real numbers. We're going to say, okay, everything is smaller or below 3. Kind of think of how you translate that in. Say all my y's are less than or equal to 3. Boom. Looking good.